April, 1940. Copenhagen, Denmark. The air outside is literally vibrating with the mechanical rhythmic thud of Nazi boots against cobblestone. The German military machine is pouring into the city, and the country is fundamentally falling. But if you step inside the quiet walls of a very specific theoretical physics institute, you do not find people cowering, and you don't find them simply burning papers. Instead, you find a scene ripped entirely from a cinematic thriller, a visceral reality that completely shatters the conventional image we hold of detached, dusty academics living in an abstract world of chalkboards and equations. Two scientists are standing over a laboratory bench, staring into a fuming, bubbling vat of a highly corrosive acid mixture, aqua regia, royal water. It is turning a furious, toxic, boiling orange color. Frantically, they are dropping heavy, 23-karat pure gold Nobel Prize medals, specifically those belonging to Max von Laue and James Franck, into this acid, literally dissolving the highest physical honors in the scientific world into an unrecognizable liquid solution. All of this, just to hide them from the advancing Gestapo. The man who directed that institute, Niels Bohr, lived a life completely devoid of theoretical safety. He was a man who dedicated his entire existence to uncovering the most deeply hidden, invisible secrets of the universe, only to find himself struggling to navigate an incredibly violent world that tragically weaponized his beautiful mathematical discoveries to build the ultimate instrument of mass extinction. Before we pull back the curtain on the epic intellectual rivalries, the bitter, devastating personal tragedies, and the profound mysteries of Niels Bohr, take a moment to like, share, and subscribe to Legendary Lives Unveiled. Join us in the shadows of history as we continue to unearth the hidden truths of the world's most brilliant and often tragic minds. To truly understand the mechanics of Bohr's mind, we cannot start with his physics. We must examine the highly unusual intellectual crucible that formed his worldview, the environment of the Panum House in late 19th century Copenhagen. Born in 1885 into practically Danish intellectual royalty, his father, Christian Bohr, was a twice Nobel-nominated pioneer in respiratory physiology, while his mother, Ellen Adler, came from a remarkably wealthy, socially prominent Jewish banking family. It was a potent synthesis, extreme scientific rigor, combined with immense cultural and financial capital, an ecosystem specifically optimized to produce a polymath. But the true wealth was intellectual. Christian Bohr hosted regular, intense, interdisciplinary discussion groups right at the family dinner table, bringing in heavy hitters like the philosopher Harold Höfting, the physicist Christiansen, and the linguist Wilhelm Thomsen. Young Niels and his brother Harold were not relegated to the nursery. They were kept at the table, expected to absorb debates that bridged the gap between empirical science and existential philosophy. When Höfting would discuss the philosophy of Søren Kierkegaard, specifically Kierkegaard's ideas of the subjective nature of truth and the leaps of faith required to cross logical gaps, Niels was internalizing a terrifying concept. He learned that human language and human perception are inherently flawed tools for describing ultimate reality. This interdisciplinary bedrock forged a cognitive style that was highly unusual, especially when compared to his brother. Harold Bohr was the prototypical textbook prodigy, a brilliant mathematician, quick-witted, charismatic, and a literal superstar who won a silver medal in soccer for the Danish national team at the 1908 London Olympics. Niels played goalie for the exact same prestigious Copenhagen club, but he was fundamentally different. He was agonizingly slow to articulate his thoughts. During a critical match, the opposing team launched a long shot toward the goal. Niels just stood there, frozen. He completely missed the save because he was literally leaning against the wooden goalpost, using a piece of chalk to perform mathematical calculations on the frame. Physically robust, his mind was perpetually caught in a vast, complex web of abstract thought. In his grammar school, despite being universally recognized as brilliant, his highest marks were consistently in physical education, and his extreme slowness in speech was frequently misinterpreted by peers as being dim. But it was not a lack of processing power. It was an extreme, almost paralyzing demand for precision. He absolutely refused to articulate a thought until he had examined it from every conceivable philosophical and mathematical angle. Beneath that quiet, deliberate exterior, however, was a streak of sheer rebellious audacity. In 1905, as a 20-year-old undergraduate, he faced a challenge from the Royal Danish Academy of Sciences. Measure the surface tension of liquids using oscillating fluid jets. A highly complex theoretical and practical problem proposed years earlier by Lord Rayleigh for a student at the University of Copenhagen, an institution that notably did not even possess a dedicated physics laboratory. It should have been impossible. Instead, he bypassed the institution. He hijacked his father's physiology laboratory. When the necessary equipment didn't exist, Bohr simply taught himself advanced glassblowing. He spent night after night over a high-temperature flame, painstakingly crafting his own elliptical glass test tubes from scratch just to create the perfect, unvarying water jets. But the intellectual labor is what actually won him the gold medal. He realized Lord Rayleigh's original theoretical framework was incomplete. Bohr independently extended the mathematics, factoring in the viscosity of the water and the complex aerodynamics of the surrounding air, to perfectly correct the theoretical models, submitting his sprawling, painstakingly detailed essay at the very last possible minute. Yet, this exact demand for precision eventually led him to an absolute, undeniable wall. By 1911, he completed his PhD thesis on the electron theory of metals, a masterpiece of classical theoretical physics that utterly failed to explain the magnetic properties of those metals. Bohr didn't try to fudge the numbers. He explicitly concluded that classical physics, the physics of Newton and James Clerk Maxwell, was fundamentally incapable of explaining magnetic phenomena. The mechanical, deterministic laws governing the macro-universe completely broke down at the atomic scale. He had to seek out the titans of the field. In 1911, deeply funded by a Carlsberg Foundation grant, he arrived at Cambridge to work with J.J. Thomson, the living legend who discovered the electron in 1897 and proposed the prevailing plum pudding model of the atom. It was a catastrophic mismatch. Thomson was an experimentalist who loved brass instruments and tangible results. Bohr, whose mind operated entirely in philosophical abstraction, walked into Thomson's office, opened a copy of a book Thomson himself had written, pointed to a specific equation, and in broken English informed the great man that his mathematics were incorrect. Ignored and relegated to mundane tasks, Bohr completely bailed. He headed to Manchester to work with a completely different scientific force, Ernest Rutherford. Rutherford had just literally blown up Thomson's plum pudding model by firing alpha particles at a microscopic sheet of gold foil. When a tiny fraction bounced violently backward, Rutherford concluded the atom is almost entirely empty space, with virtually all its mass concentrated in an unimaginably dense, positively charged nucleus. He proposed the planetary model. The nucleus is the sun, the electrons are the planets. It was elegant, it made intuitive sense, and mathematically, it was completely doomed. Bohr saw the fatal flaw immediately within classical electromagnetism, specifically the Larmor formula. The laws of physics dictate that any charged particle undergoing acceleration must continuously radiate electromagnetic energy. An electron moving in a circular orbit is constantly changing direction, constantly accelerating, and therefore must be bleeding energy in the form of light. Its orbit must decay. It should spiral inward, moving faster and faster, emitting a continuous smear of radiation until it crashes into the nucleus. Run the math using classical physics, and Rutherford's atom should collapse in roughly 100 trillionth of a second. Matter cannot exist. The earth beneath you, your own biological structure. It should all instantly implode into a microscopic singularity. Faced with imminent mathematical collapse, Bohr committed pure scientific heresy. He simply threw out classical mechanics. He turned to the quantum theories of Max Planck and Albert Einstein. Planck had proposed that electromagnetic energy is emitted or absorbed in discrete, indivisible packets called quanta. Bohr forced this abstract idea onto Rutherford's physical atom. He dictated a totally new reality. Electrons do not spiral inward. They are strictly confined to very specific, mathematically fixed stable orbits, simply disobeying classical electromagnetism and not radiating energy while in these stationary states. But to explain how electrons change energy levels, he introduced a concept that completely broke the minds of the old guard: the quantum leap. An electron moving from a higher energy orbit to a lower energy orbit doesn't travel through the space between them. It disappears from the outer orbit and instantaneously materializes in the inner orbit. It violated the core tenet of Newtonian continuity: natura non facit saltus. Nature does not make jumps. Bohr was saying that nature only makes jumps, and he proved it. A Swiss mathematician named Johann Balmer had figured out a formula predicting the mathematical spacing of the specific barcode-like lines of color: red, blue-green, blue-violet, emitted by heated hydrogen gas, the Balmer series. Bohr demonstrated that these specific spectral lines are the exact flashes of light, the exact photons, emitted when an electron makes a quantum leap. Running the math using Planck's constant, the mass of the electron, and the charge of the electron, he calculated the Rydberg constant with astonishing precision. He published this in 1913 in a series of papers known as the Trilogy, fundamentally altering the trajectory of human understanding and earning him the Nobel Prize in Physics in 1922. But left to his own devices, those papers might have been an unreadable, impenetrable mess. Enter Margrethe Nørlund. Married to Bohr in 1912, she was not a physicist, but she became the absolute critical catalyst for the quantum revolution. She became his full-time transcriber, editor, and intellectual sounding board. Bohr would endlessly pace their study, dictating his thoughts aloud, wrestling with abstract concepts, and Margrethe would type. When his loops became too convoluted, she stopped him. She demanded he explain the mechanics of the atom in a plain language that was logically coherent. She provided the cognitive scaffolding that allowed Bohr to export the quantum leap from his own mind into the collective consciousness of the scientific world. But this monumental triumph was only the prologue. A collaborative paradise was about to be built, and it would soon become the command center for the greatest, most consequential philosophical war in the history of science. With the Nobel Prize secured, you'd expect Bohr to retreat into a solitary life of theory. Instead, he orchestrated a completely unprecedented academic experiment. In 1921, he successfully lobbied the Danish government and private donors to found the Institute for Theoretical Physics at the University of Copenhagen. But the financial engine driving this intellectual utopia was highly unconventional. It was heavily bankrolled by the Carlsberg Brewery, the massive beer conglomerate. By 1932, the Royal Danish Academy, backed by Carlsberg, granted Bohr the lifelong use of the palatial Carlsberg mansion. Imagine a modern tech incubator, but housed in a palatial estate, funded by a beer company, and filled with residents trying to decode the fabric of reality. The environment he cultivated there, globally known as the Copenhagen spirit, was completely devoid of the rigid hierarchical formality that plagued German and British universities. It was chaotic, vibrant, and fiercely egalitarian. A generation of young, arrogant, brilliant physicists converged on Copenhagen. Werner Heisenberg, Wolfgang Pauli, Paul Dirac, Max Born. They played tense games of ping-pong, watched American cowboy movies to clear their heads, and filled chalkboards with dense mathematics. Bohr sat at the center of this hurricane, acting as the ultimate intellectual father figure and mediator. Puffing endlessly on his pipe, his voice barely a whisper, he forced speakers to defend every single assumption. He loved it when Pauli or Heisenberg would fiercely attack a new theory, firmly believing that truth was only forged in the crucible of extreme debate. His guiding ethos was brutal but simple. Never express yourself more clearly than you can think. This relentless pursuit of clarity was vital, because the physics of the 1920s was becoming increasingly bizarre. The beautiful, easily visualized solar system model of the atom Bohr had built in 1913 was falling apart. The mathematics of Heisenberg and Erwin Schrödinger were revealing a microscopic world that defied all human intuition. And this collaborative paradise of Copenhagen was about to become the command center for the greatest, most consequential philosophical war in the history of science. A war against Albert Einstein. The rupture was not about mathematics. It was about the fundamental nature of reality itself. Classical physics dictated absolute determinism. If you know the exact position, velocity, and forces acting upon every particle, you can mathematically predict the entire future of the universe. Pierre-Simon Laplace's demon. But the new quantum mechanics, specifically Heisenberg's uncertainty principle and Max Born's probability wave interpretation, destroyed that clockwork. They proved that at the atomic level, you cannot know both the exact position and the exact momentum of a particle simultaneously. You cannot predict the exact outcome of a single quantum event like radioactive decay. You can only calculate the probability of it happening. The universe was no longer a clock. It was a casino. Bohr elevated this mathematical weirdness into a comprehensive philosophical framework. The complementarity principle, his masterpiece. Experiments were showing light and electrons acting as a continuous wave in some setups and as discrete particles in others. How can something be both localized and spread out? Bohr's radical answer: they are neither until you look at them. The observer and the observed are fundamentally entangled. The very act of measuring forces the quantum system to collapse into a defined state. There is no deep, hidden, objective, real world churning away beneath the quantum mathematics. The probabilities are the reality. As his colleague, John Archibald Wheeler, later put it, no elementary phenomenon is a phenomenon until it is an observed phenomenon. Albert Einstein violently, categorically rejected this. He believed in strict causality, an objective reality independent of human measurement. He famously summarized his disgust by declaring, "God does not play dice with the universe." To which Bohr supposedly replied, "Einstein, stop telling God what to do." Einstein believed quantum mechanics was merely a statistical approximation, an incomplete theory lacking hidden variables that would one day restore determinism. This friction exploded into outright warfare at the 1930 Solvay Conference in Brussels, the heavyweight championship of human intellect. Einstein arrived with a singular goal: to utterly destroy Heisenberg's uncertainty principle. He ambushed Bohr with an incredibly elegant thought experiment known as the photon box. Imagine a box completely sealed off from the universe, filled with light. Inside is a precise clock, hooked to a shutter mechanism on the wall, and the entire box is suspended on an incredibly sensitive spring scale. The clock opens the shutter for a microscopic fraction of a second. Exactly one photon escapes. Time is measured perfectly. Then Einstein invoked his own monumental discovery, special relativity, E equals mc squared. Because the photon carries energy, it must have an equivalent mass. When it escapes, the total mass of the box decreases. By reading the spring scale before and after the shutter opens, you calculate the exact mass lost and convert that into the exact energy of the escaped photon. It was a lethal blow. Einstein had designed an apparatus that measured both exact time and exact energy simultaneously with zero uncertainty, a direct violation of Heisenberg's equation. If Einstein's logic held, the uncertainty principle was a mathematical fiction, and the entire foundation of quantum mechanics collapsed. The accounts of Bohr that evening are heartbreaking. Paul Ehrenfest, a mutual friend, described Bohr physically trembling, pacing the halls of the hotel in a state of absolute panic. He went from physicist to physicist, pleading with them to find the flaw, muttering that if Einstein was right, it meant the end of physics. He went to sleep a defeated man, staring into the destruction of his life's work. But when he emerged for breakfast the next morning, the panic was gone. His counterattack is arguably the most brilliant, poetic, intellectual judo move in the history of science. He used Albert Einstein to defeat Albert Einstein. Bohr realized that when the box loses mass, the tension on the spring pulls the box slightly upward against the gravitational pull of the Earth. The box physically moves within the gravitational field. And according to Einstein's own crowning achievement, the general theory of relativity, published in 1915, gravity bends time. The closer you are to a massive object like the Earth, the slower your clock ticks. Because the box moved upwards into a slightly weaker gravitational field, the clock's rate of ticking fundamentally changed during the experiment. The movement introduced a fundamental uncertainty into the reading of the clock. Bohr mathematically proved that the uncertainty in the gravitational time dilation perfectly matched the limits demanded by Heisenberg's equation. Einstein was forced to concede, but he never surrendered his belief in a deterministic reality. In 1935, alongside Boris Podolsky and Nathan Rosen, he published the EPR paradox, abandoning his attack on uncertainty to focus entirely on quantum entanglement. They argued about two entangled electrons, one fired to New York, one to Tokyo, existing in a superposition of spin-up and spin-down. If New York measures spin-up, Tokyo instantaneously collapses into a spin-down state. The information would have to travel faster than light, which special relativity explicitly forbids. Einstein mockingly called this spooky action at a distance, arguing that hidden variables must have defined the spins from the beginning. Bohr ferociously defended complementarity, arguing it is meaningless to consider the electrons independent. They are a single, holistic quantum system. Decades later, the physicist John Bell developed a mathematical theorem proving definitively that Bohr was right. Hidden variables do not exist, and spooky action at a distance is a fundamental feature of our universe. But while they debated the philosophical nature of the theoretical atom, the real world was descending into madness. By late 1938, German chemists Otto Hahn and Fritz Strassmann successfully induced nuclear fission by bombarding uranium with neutrons. Lisa Meitner and Otto Frisch provided the theoretical explanation, realizing the uranium nucleus was splitting in half, converting mass into massive kinetic energy. perfectly validating E equals mc squared. Bohr brought this horrifying news to the United States in early 1939, terrified the American scientific community, and eventually catalyzed the Manhattan Project. By April 1940, the geopolitical nightmare arrived at his doorstep. The German war machine occupied Denmark. Bohr's institute became a literal sanctuary as he tirelessly funneled Jewish scientists and refugees out of occupied Europe under suffocating paranoia. Then, September 1941, a knock at the door. Werner Heisenberg arrived in occupied Copenhagen. Heisenberg was Bohr's golden boy, the brilliant architect of the uncertainty principle who had been like a son to him. But now, Heisenberg was the director of the German nuclear weapons program, actively working for the Nazi regime. Knowing the Gestapo had bugged the institute, the two men took a walk in a public park, the Feldparken. Because it was outside, there are no transcripts, no recordings. The historical debate over this walk is so profound, it spawned Michael Frayn's Tony Award-winning play, Copenhagen. The ambiguity lies in their violently conflicting accounts. Years later, in a letter to the author Robert Jungk, Heisenberg claimed he was a covert pacifist on a deeply moral, treasonous mission. He claimed he wanted to subtly propose a mutual strike, signaling that if the Allies didn't build the bomb, German scientists could stall Hitler's program and save the world from nuclear fire. For decades, Bohr remained publicly silent, a deeply repressed anger. It wasn't until 2002, long after his death, that his family released a cache of unsent letters Bohr had agonized over in the late 1950s after reading Jungk's book. Reading those drafts is chilling. Bohr's memory of that walk was an absolute nightmare. There was no subtle offer of a mutual strike, no pacifism. Bohr explicitly stated that Heisenberg was brimming with confidence, boasting that he had spent 2 years focused exclusively on the military applications of atomic energy. Heisenberg gave the terrifying impression that a German atomic bomb was not only possible, but inevitable, and callously stated that Germany was going to win the war, insisting the Danes simply accept the new European order. Was Heisenberg lying through his teeth to save his legacy? Or was Bohr, a man whose homeland had been stolen and whose Jewish heritage put a target on his back, simply incapable of hearing a coded message of peace from a man wearing the aura of the oppressor? When the architect of the Nazi nuclear program tells you he is working on a bomb, you don't look for hidden pacifist codes. You hear a death sentence. That meeting permanently poisoned their scientific father-son dynamic. More importantly, it convinced Bohr of an absolute geopolitical reality. The Nazis were building the bomb, and Heisenberg possessed the intellect to succeed. The threat of a nuclear-armed Hitler was no longer theoretical. It was an imminent ticking clock. 2 years later, the ticking clock finally ran out for Bohr himself, September 1943. The relatively lenient occupation of Denmark ends, and the German military imposes martial law. In the shadows, Bohr receives a terrifying, highly classified leak from a sympathetic contact within the German diplomatic corps. The Gestapo is launching a massive raid in a matter of days. Every Danish Jew, including Niels Bohr and his family, is slated for immediate arrest and deportation to the concentration camps. Bohr's life instantly transitions from abstract physics to desperate survival. He and Margrethe are forced to abandon their home, their institute, their entire lives. Under the cover of darkness, they sneak aboard a small fishing vessel. They endure a perilous, freezing night crossing the Øresund Strait, dodging German patrols, until they finally reach the shores of neutral Sweden. But the moment he steps off that boat, he does not just go into hiding. He recognizes the immense power of his international reputation, and he wields it like a weapon. Bypassing all diplomatic protocol, he forcefully demands and secures an immediate face-to-face audience with King Gustav V of Sweden. He implores the king to abandon Sweden's quiet neutrality on this issue and to publicly broadcast an offer of asylum to all Danish Jews. He argues that a public declaration over the radio will force the German authorities to hesitate and give the Danish resistance the legal mandate they need. And it works. The Swedish government makes the broadcast. That diplomatic cover provides the crucial political space for the Danish resistance to execute one of the most remarkable civilian rescue operations in military history. Over the next few weeks, ordinary Danish citizens using fishing boats and ferries secretly smuggle over 7,000 Jewish men, women, and children across the strait to safety. Bohr's intervention was a vital catalyst in saving almost the entire Jewish population of Denmark from the Holocaust, a testament to his profound moral courage. But the Allied intelligence agencies knew he couldn't stay in Sweden. He was too valuable, and German assassins operated freely in Stockholm. The British government initiates a highly classified extraction operation, sending a de Havilland Mosquito, an unarmed, high-speed, twin-engine wooden bomber, to retrieve him. But the Mosquito is a combat aircraft. It doesn't have a passenger cabin. So, what is the British military solution for transporting a 58-year-old internationally treasured Nobel laureate across enemy airspace? They literally strap him into the empty bomb bay of the plane. He is lying flat on the bomb rack doors, with only a parachute and a flight helmet equipped with an intercom and an oxygen mask. To evade German anti-aircraft fire and Luftwaffe interceptors over the North Sea, the pilot has to fly at extremely high altitudes where the air is catastrophically thin. The pilot gets on the intercom and tells Bohr to turn on his oxygen supply. But here, a bizarre, almost comical physical reality intersects with near tragedy. Bohr had an unusually massive head. His cranium was physically huge. The standard issue British flight helmet didn't fit him properly. It sat too high, completely covering his ears and muffling the intercom. He never hears the pilot's command. As the plane climbs, Bohr is slowly asphyxiated. He loses consciousness due to extreme hypoxia. The pilot, realizing he has lost communication, understands his high-value cargo is likely dying in the bomb bay. He executes a steep emergency dive over the ocean, dropping to a lower altitude where the air is breathable. Bohr regains consciousness just as they land in Scotland, having narrowly survived the extraction. From the UK, he is ushered across the Atlantic, operating under the incredibly thin, secret alias Nicholas Baker. Transported into the desolate, heavily guarded deserts of New Mexico, he arrives at Los Alamos. He is now officially a member of the Manhattan Project, which presents a profound ethical paradox. How does a mind wired for such profound empathy, a fiercely humanitarian figure who risked his life to save refugees, justify participating in an industrial complex dedicated solely to creating the most devastating weapon of mass slaughter in human history? It requires a brutal calculation of lesser evils. Bohr's justification was rooted deeply in the terror of his 1941 meeting with Heisenberg. He firmly believed that atomic weapons were an inevitability dictated by the laws of physics. Since the nucleus could be split, someone would build the bomb. If Hitler achieved it first, it meant a 1,000-year dark age of global fascism. The Allies simply had to possess the deterrent. However, his role at Los Alamos was unique. J. Robert Oppenheimer, the brilliant and neurotic director of the laboratory, did not bring Bohr in to do the daily grinding mathematical calculations. Oppenheimer recognized that the young, incredibly brilliant scientists men like Richard Feynman, were operating under crushing psychological pressure. Bohr was brought in to be the ultimate scientific father figure, the intellectual conscience of the project. He would walk through the compound, asking his trademark-piercing questions, forcing the engineers to clarify their assumptions. He did make specific technical contributions, most notably helping to refine the design of the modulated neutron initiator, the highly complex mechanism required to inject neutrons into the plutonium core at the exact microsecond of implosion. But almost from the moment he arrived, his primary focus shifted entirely to the geopolitics of the weapon's existence. Bohr possessed an astonishingly prophetic vision. He looked past the immediate war with Germany and Japan. He realized that the atomic bomb was not merely a larger artillery shell. It represented a fundamental phase shift in human history. The bomb made traditional war obsolete. In a future where multiple nations possessed nuclear weapons, any direct military conflict would inevitably escalate into total global annihilation. Therefore, he deduced that the only way to ensure human survival in the nuclear age was through absolute, radical transparency. Throughout 1944 and 1945, he practically ignored the physics, dedicating all his energy to desperately lobbying the political leadership of the Allied world. He managed to secure private meetings with both U.S. President Franklin D. Roosevelt and British Prime Minister Winston Churchill. His proposal to them was politically radioactive. He argued that the United States and Great Britain must proactively contact the Soviet Union and share the fundamental secrets of nuclear energy before the bomb was ever finalized or dropped. He insisted that Joseph Stalin's spies likely already knew about the Manhattan Project, and that maintaining a posture of Anglo-American nuclear supremacy would inevitably breed deep suspicion in Moscow, sparking a desperate, paranoid post-war nuclear arms race. If the Allies approached the Soviets with an open hand, proposing an international, veto-free system of shared control, they could build unprecedented geopolitical trust and prevent a Cold War. Try pitching radical scientific transparency with Joseph Stalin to Winston Churchill in 1944. The meeting was an unmitigated disaster. Churchill, a staunch imperialist who viewed the atomic bomb as the ultimate guarantor of post-war British and American hegemony, was apoplectic. When Bohr, with his quiet, mumbling voice and complex philosophical arguments, suggested handing this absolute power to the communists, Churchill was completely furious. He dismissed Bohr's ideas as dangerously naive, bordering on outright treason. Churchill was so angered that he wrote a memo suggesting Bohr was a severe security risk who should be heavily monitored, perhaps even imprisoned, to prevent him from leaking information to the Russians. Bohr's prophetic warnings fell entirely on deaf ears. The bombs were dropped on Hiroshima and Nagasaki. Hundreds of thousands of civilians were vaporized or poisoned by radiation. The war ended, but the geopolitical nightmare Bohr had accurately predicted. The paranoid, terrifying, decades-long Cold War nuclear arms race began exactly as he feared. He returned to Copenhagen after the war, a man deeply burdened by the reality of what his theoretical physics had unleashed upon humanity. But we cannot truly comprehend the psychological weight Bohr carried in his later years without confronting the devastating personal tragedies he endured. We often view historical figures through the macro lens of geopolitics and science. But Bohr was a father. Niels and Margrethe Bohr had a vibrant, loving household with 6 sons. But they were forced to endure the unimaginable pain of burying 2 of them. Their son Harald, named after Niels's brother, contracted severe meningitis and died when he was around 10 years old. The loss of a child to illness is a crushing blow. But the death of his eldest son, Christian, is a moment of such visceral, helpless horror that it defies language. It occurred in the summer of 1934. Bohr, his 18-year-old son Christian, and two friends were sailing in the Kattegat Sea. They were experienced sailors, but a sudden, freakishly violent squall materialized. The wind violently shifted the boom of the boat. Christian was struck and swept instantly overboard into the churning, freezing water. Put yourself in Bohr's mind in that exact moment. You are a man whose intellect can grasp the invisible architecture of the universe. You have solved the deepest mysteries of nature. And yet, standing on the deck of that violently pitching boat, desperately searching the dark water for your child, you are reduced to absolute, terrifying impotence. The storm was too fierce. They could not turn the boat around in time. Christian drowned. Bohr watched his son vanish beneath the waves, utterly powerless to save him. How does a human consciousness survive that level of catastrophic trauma without completely fracturing? The answer lies in the very philosophy he developed to understand the atom, the principle of complementarity. The idea that you must hold two opposing, seemingly mutually exclusive truths in your mind simultaneously to grasp the whole picture. Light is both a wave and a particle. Bohr applied this physical epistemology to his emotional reality. He had to accept that he existed in a universe where he could experience the transcendent, rational beauty of uncovering the deepest secrets of nature, while simultaneously existing in a universe governed by chaotic, irrational, brutal cruelty. He recognized that the triumph of scientific mastery and the crushing impotence of human grief are complementary realities. One does not negate the other. You cannot solve grief with a mathematical equation, just as you cannot mourn an electron. He forced himself to accept the profound duality of existence. He did not let the trauma of his son's death or the political failure of his nuclear diplomacy break his spirit. Instead, he channeled that immense emotional weight into a tireless, decades-long crusade for global peace. From 1945 until his death in 1962, he drafted a massive, incredibly detailed open letter to the United Nations in 1950. He organized the first Atoms for Peace conference in Geneva in 1955. And most successfully, he became a primary architect in the founding of CERN, the European Organization for Nuclear Research. CERN is the ultimate physical manifestation of the Copenhagen spirit, built to ensure that physicists from all over Europe, even from nations that had just spent 6 years slaughtering each other, could share data openly and probe the universe in the name of pure, peaceful science, strictly decoupled from any military application. For this relentless dedication, he was awarded the very first Atoms for Peace Award in 1957. There is one visual artifact from Bohr's later life that perfectly synthesizes the monumental complexities of the man. In 1947, the King of Denmark bestowed upon Bohr the Order of the Elephant, the absolute highest honor in the Danish kingdom, reserved exclusively for royalty and foreign heads of state. Custom dictated that Bohr design his own personal family coat of arms to hang permanently in the chapel of Frederiksborg Castle. He did not choose imagery that celebrated his scientific dominance. There is no atom on the shield, no Danish flag, no heraldic lion. Dead center on the crest, Bohr placed the ancient Eastern symbol of the yin and yang, the dark and the light, fundamentally intertwined, mutually dependent. And inscribed above it, in Latin, is his personal motto, Contraria sunt complementa. Opposites are complementary. Bohr's entire existence was an exercise in holding two opposing truths at once. He was a terrible writer who authored a new language of physics, a man of peace who helped birth the atomic bomb, a father broken by grief who nurtured an entire generation of brilliant scientists. Perhaps his greatest legacy isn't the quantum leap. Perhaps Bohr's ultimate contribution was exposing the fundamental limits of the human brain, recognizing that our logic, our mathematics, and our very language are just evolutionary tools fundamentally inadequate to fully describe the true, terrifying, paradoxical nature of reality. We are trying to measure the infinite with a ruler made of words. If you found yourself captivated by the paradoxes of Niels Bohr, don't keep it to yourself. Like, share, and subscribe to Legendary Lives Unveiled. Drop a comment below. What other brilliant, contradictory minds should we explore next? Keep seeking the truth hidden in the contradictions.